Welcome to the deep dive. Today, we're pulling back the curtain on something really big, a force that's, well, often unseen, but it's definitely reshaping our AI world. We're talking about foundation models. And our mission here really is to unpack what these things actually are, why they're frankly so significant, and, how they're the engine behind so much of the AI you probably use every day.
Yeah, absolutely. And for this deep dive, we've gathered quite a bit of material, articles, notes, all looking into these LLM concepts, the upsides, the applications in generative AI. The sources don't detail specific risks, just to note that, but they cover a lot of ground.
Yeah.
And our goal is just to boil it down, get to the core insights for you.
Okay, great. Let's dive right in then. So the sources, they define foundation models as these large-scale AI architectures, expansive parameter scales, multimodal adaptability. But, what does that actually mean in plain English?
Right, good question. So at their core, they're really key in generative AI. That means they're good at, well, creating things really high quality text, images, even video and speech. You often hear the term used almost interchangeably with GPAI, general purpose AI. That kind of hints at how versatile they are.
Hmm.
And the jargon, expansive parameter scales. That just means they have like billions, sometimes trillions of internal variables they can adjust. It's what lets them learn complex patterns from huge data sets.
Billions or trillions.
Yeah, yeah. And multimodal adaptability means they're not stuck on just text. They can work across different types of data, images, sound, video. It sort of blurs the lines between older AI fields.
Okay, so that foundation part seems key then. How do they get to be so versatile? How does that work?
Well, they're essentially deep learning algorithms, right?
Yep.
But the crucial part is they're pre-trained. And they're pre-trained on absolutely enormous data sets often. Stuff scraped from the public internet,
Okay, pre-trained on just everything.
pretty much. And this massive pre-training lets them learn general patterns, almost like a universal language of data. Then they can transfer that knowledge to new specific tasks. So you could train a model on a huge mix of text and images, and then fine-tune it for, say, both writing articles and recognizing objects and pictures.
Ah, I see. So they're the starting point.
Exactly. They're the base layer, the foundation that more specialized models are built on top of. They really are a cornerstone of modern AI. Think ChatGPT, that's powered by a foundation model.
Right, okay. That makes a lot more sense. It's fascinating, this adaptability. But are they all, basically the same thing, or are there different types, different flavors of these models?
That's a really important point. No, they aren't all the same. While they share that core idea of large-scale pre-training, they often specialize. You could definitely say there are different flavors. So first up, you've got LLM models, large language models. These are designed specifically for processing and understanding natural language. Think language translation, answering complicated questions, generating text. Examples. BERT is a big one, really good at understanding context. GPT-3, now GPT-4, of course, famous for generating really coherent, creative text. T5 is another major one.
Got it. Language. What else?
Then you have computer vision models. Their whole purpose is processing visual stuff, images, videos. They do things like image classification, so telling you what's in a picture, object detection, finding where things are in a picture, and image segmentation, like outlining specific objects. Models like ResNet, EfficientNet, YOLO. These are workhorses in computer vision, each with its own strengths in accuracy or speed.
Right, vision. Makes sense.
And third, there are generative models. Now, these are specifically designed to create new data that looks like data they were trained on.
Ah, so the generative part of GPI we mentioned.
Exactly. This can be generating new images, new text, even new video. DALL-E is a famous example for images. You also hear about Jan's generative adversarial networks.
Yeah.
Those are interesting. They have two parts, a generator making fakes and a discriminator spotting them. They sort of babble it out and get better together.
Huh. Like a competition inside the AI.
Kind of, yeah. And VAEs, variational autoencoders, are another type in this category.
Okay, so LLMs, vision models, generative models. But is there overlap? Like you said, LLMs generate text.
Yeah.
Isn't that generative? Can a vision model also be generative?
You hit it exactly. Yes, there's definite overlap. While we might categorize them by their main input or task, many foundation models are inherently generative. An LLM writing a story, that's a generative task. A vision model creating a photorealistic image, also generative.
Yeah.
So yeah, it's maybe less about strict boxes and more about capabilities. The ability to generate new content is something many of these models have, regardless of whether we call them an LLM or a vision model first.
Interesting. Okay, so moving on a bit. The sources also talk about a couple of key trends happening in how these models are developed and used. This is where it gets really interesting, I think.
Yeah, there are two big ones worth highlighting. The first is this idea of homogenization.
Homogenization. Sounds a bit bland.
Maybe. But what it means is we're seeing a trend where just a handful of core deep learning architectures are being used to get state-of-the-art results across lots of different tasks. Like many of the best NLP models today, they're often just adaptations or tweaks of a few well-known foundation models, like the transformer architecture.
So everyone's kind of building on the same few successful blueprints.
Pretty much. It can make development faster, more efficient, because you're not reinventing the wheel.
Mhm.
But yeah, it also raises questions about diversity in approaches, maybe potential unforeseen risks if everyone relies on the same foundations.
Okay, efficiency versus maybe putting all our eggs in one basket. What's the second trend?
The second one is emergence. And this one is frankly fascinating. It's the idea that these models can sometimes show behaviors or capabilities that they weren't explicitly trained or programmed to do.
Wait, like unexpected skills?
Exactly. Think about a model trained purely on text, maybe predicting the next word. Suddenly, it might develop an ability to write decent computer code, or show basic reasoning, or even translate languages it wasn't specifically taught.
Whoa, how does that even happen?
That's the million-dollar question. It seems to be a property of scale. These massive models, trained on diverse data, somehow develop these extra abilities as a side effect. And these emergent behaviors, they can be incredibly useful, unlocking new applications, or, potentially problematic if they lead to unintended consequences. It's something researchers are watching very closely.
So homogenization means using fewer core designs, and emergence means those designs might surprise us with what they can do. What does all that mean for us then, for the future?
Well, homogenization suggests maybe a future where AI development relies on refining and scaling a few super powerful core models, potentially faster progress maybe, and emergence. That just adds a whole layer of unpredictability
Yeah.
and, frankly, potential. AI developing skills beyond its training. That's huge. It means we need to be really thoughtful about development, testing, and understand what these models are actually learning.
Right. It sounds like we get efficiency, but also complexity and maybe less predictability.
Right.
Okay, let's pivot to the practical side. We understand a bit more about what they are and these trends. Where are we actually seeing foundation models making a difference today? You mentioned ChatGPT, but what else? The potential seems enormous.
Oh, it really is. The applications are spreading out across loads of sectors. Our sources highlight quite a few. For instance, industrial applications. This is pretty cool. Factories and warehouses are using them to build digital twins.
Digital twins, like a virtual copy.
Exactly. A super realistic simulation of their whole operation. They can then use the model to test out new layouts, different workflows, maybe simulate robot movements, all in the virtual world first.
Ah, so you can find efficiencies or problems without messing up the real factory floor.
Precisely. It's a safe space to experiment and optimize. Big potential for refining processes.
Okay, that's compelling. What else?
Well, then there's a whole area of communication and content. We see them in customer support chatbots, tools that help write marketing copy, platforms for content generation, also much better translation and localization services, and tools that can summarize long documents or articles automatically.
Yeah, I've seen some of those summarization tools. Pretty useful.
Definitely. And in information management, they're great for pulling specific information out of huge amounts of text that's information extraction. Also, named entity recognition, or NER. Yeah, that's like automatically finding and tagging things like people's names, company names, locations in text. Super useful for organizing data. Plus, sentiment analysis, figuring out if text is positive or negative, and spotting trends in market data or social media.
So handling and understanding massive amounts of information.
Exactly. And then there are more specialized areas. The creative industries are using them for generating art, music ideas. Education is exploring personalized learning content. Finance uses them for analysis and reporting. Even healthcare streamlining clinical notes, helping doctors find relevant health information faster. And legal tech for compliance and document review.
Wow, it really is touching almost everywhere.
That's a broad sweep, absolutely.
You know, looking at that list, what stands out to you? For me, it's not just automation. It feels like it's actually changing how these industries work. That digital twin example.
Yeah.
That's about thinking differently, preventing problems.
I agree completely. It's the adaptability. They're not just single-task tools. They enable fundamentally new approaches. And just to be thorough, The source material we looked at does briefly mention a section on limitations of foundational models, but honestly, there weren't specific details provided on what those limitations are in the notes we had. So we can acknowledge they exist, but can't really elaborate based on this material.
Okay, fair enough. Sticking to the sources. So, kind of wrapping things up here, it feels like the big takeaway is that these foundation models, these huge pre-trained deep learning algorithms, they really are the foundation for so much of modern AI. They're the starting blocks for specialized tools and have obviously turbocharged things like ChatGPT that many of us now use.
Absolutely. And we've seen they come in different flavors. They're shaped by trends like homogenization and this really intriguing emergence phenomenon. They are, without a doubt, fundamental building blocks. Adaptable, powerful, and still evolving rapidly.
Which leads to maybe a final thought for you listening out there. Given everything we've discussed, their power to transfer knowledge, this ability to adapt across totally different areas, and especially this emergence, these unexpected capabilities, how might these models continue to reshape things? Not just specific jobs or industries, but maybe the very way we interact with technology, how we even think about intelligence itself. Could they change things in ways we can barely even imagine right now? Something to definitely ponder. Well, that's all the time we have for this deep dive. Thanks so much for joining us. We'll catch you next time.